Hello everyone, this is Dr. Ogrukmaz, and this is the first video of Module 0, which we are going to learn advanced Excel applications in business cases. And today, in companies both large and small, spreadsheet modeling is the most popular decision support tool used by managers across different functional areas such as accounting, finance, marketing, and sales and operations. Spreadsheet modeling is the use of spreadsheet programs, which is in this case Microsoft Excel, to implement decision models. A decision model is the generalization of the relationships between inputs and outputs of a decision. It's often used to predict the outcomes of decisions given certain input values or actions. For example, a pricing model estimates the relationship between different levels of price levels, which are the inputs of the model, and market demand for the product, which is the model output, or between price levels and potential revenues and profits, which in this case revenue and profit becomes model output. It helps determine the market's price tolerance or the firm's financial performance given the price levels determined by the company. Similarly, a staffing model illustrates the relationship between various capacity requirements, labor costs, and productivity, which are model inputs, and desired staffing level, which is model output, and estimates the optimal staffing level for meeting the capacity requirements and minimizing labor costs. So all decision models are designed to predict outputs based on the model inputs. A spreadsheet model is a computer-based system that expresses the relationship between inputs and outputs through mathematical and logical functions. When the model inputs change, a spreadsheet model performs recalculations to estimate new outputs, and it gives managers power to conduct what-if analysis by asking questions such as, if we hire one more experimental software developer, how would it impact the project team's ability to meet the delivery deadline? So there are two types of decision models. One is deterministic and the other one is stochastic or probabilistic model. In a deterministic model, all model parameters are known with certainty and the output of the model is fully determined by the model parameters. In other words, a given input will always produce the same output. For example, a regional airline knows exactly what the labor, fuel, and plane maintenance costs are for a certain flight. If it decides to charge $350 for each plane ticket, the airline would be able to compute the total profit for the flight, assuming all the seats on the plane are filled. Deterministic models are often represented by mathematical formulas, which allow us to understand how each input variable affects the output. The spreadsheet models that we will explore in this module are all deterministic models. A stochastic model, on the other hand, incorporates some randomness in the model. Therefore, the model will produce different outputs even with the same inputs. The model allows the user to take uncertainty into account and to evaluate decisions that may produce a range of possible outcomes. A stochastic model often includes both a deterministic component and a random error component. For example, while the regional airline in the earlier example that I explained can predict the profit for a flight in a perfect world, it must incorporate the impact of uncertain conditions such as bad weather, an energy crisis, and labor disputes on profit. Flight delays, cancellations, and cost increases caused by these uncertain conditions tend to result in very high variability in airline profit. There are three primary components in a decision model: target outputs, input variables, and processes. The target output are the outcome values of a decision that we wish to know. For example, in a pricing model designed to help identify the price level that would maximize the firm's profit, the target output is the profit, because we want to maximize the profit. The input variables include both controllable and uncontrollable variables. Controllable variables are the inputs that can be either controlled or predicted accurately. For example, in the pricing model, the price level is controlled and can be adjusted by the user, thus it's a controllable input variable. The cost of producing a unit of product can be predicted accurately by the user, Therefore, it's also a controllable input variable. Uncontrollable input variables are the inputs that can be neither controlled nor predicted accurately. For example, the total units sold cannot be controlled or predicted accurately as it depends on the market demand for the product, the price tolerance of the buyers, and other factors that cannot be identified. Therefore, it is an uncontrollable variable. In some cases, input variables are referred to as assumptions in a spreadsheet model because they are intended to be manipulated by the user to affect the target output. The processes are the intermediate and final calculations that link inputs with outputs, and they are among the key building blocks of the decision model. Embedded in the calculations are the assumptions and business rules to which the firm subscribes. For example, the way that profit is computed, when the sales commissions are paid, or how machinery depreciation is amortized are business rules unique to each organization. The processes are often expressed as a mathematical and logical formulas in a spreadsheet model. While using formulas and functions involves an understanding of spreadsheet syntax, crafting a well-structured spreadsheet requires critical thinking and creativity. We usually build a spreadsheet model to represent simplified reality with the goals of solving a real-world problem, performing data analysis, and gaining insightful information. Ideally, a spreadsheet model should allow users to easily experiment with different assumptions, evaluate and compare different scenarios, and more importantly, improve decision-making. Spreadsheet modeling is more an art than a science, and it takes experience to hone the craft. There are principles to constructing a spreadsheet model. The spreadsheet model should be well organized. Similar information should be grouped together, clearly labeled, and use the same format. The spreadsheet model should allow users to experiment with different scenarios based on input variables which are stored in individual cells and separately from the data. When entering a formula, careful consideration should be given to the choice of absolute, relative, and mixed references so that the formula can be copied to other cells that require similar calculations. Output, including charts, should be clearly labeled and appropriately formatted. Users should be able to easily identify and understand the results. So, in this video, I'm going to introduce a business case, and then we will work on solution using the Excel functions in the next video. So in this case example, Sarah Washington, a manager at Iniesta Consulting Group, oversees a team of business consultants. Each of her team members has a highly specialized expertise that is crucial to the success of her consulting group. Sarah wants to examine the after-tax earnings of her team members to ensure that their salary remains competitive compared to the salaries offered by competing firms. Iniesta offers each employee medical benefits, but each employee is required to pay a co-premium, which is a portion of their medical insurance costs. The annual co-premium amount differs between a management employee, which is $1,800, and a non-management employee, which is $1,250. Even though Iniesta's medical benefits are much better than those offered by other employers, the co-premium reduces an employee's net earnings. Sarah collects salary information of her team members and income tax rates in an Excel spreadsheet shown here in this slide. Sarah's spreadsheet organizes the 5 employees into a table with each column containing a similar information. Each row is a simplified model representing an employee. All columns are clearly labeled with column headings and appropriately formatted. For example, a dollar sign and no decimal places for the salary column. In addition, the input variables such as the insurance co-premium and income tax rates are stored in separate cells below the data. This way, if Sarah wants to experiment with different scenarios, such as reducing the insurance co-premium cost for non-management employers, she can simply change the value in these individual cells. Now, in the next video, I'm going to show how to calculate the net salary using Excel functions. Thank you for watching this video.